All right, so this picking up on lesson 6-1, picking up on number 10. So it says, suppose you got a roller coaster called Cougar Mountain that immediately started to climb a track in a linear fashion as shown. All right, so we have our graph here, and a lot like our graph that we already had, we go ahead and we start kind of noticing our things, right? We notice that, again, this is our x axis here. We notice again that this is our y-axis. We notice that the graph is a lot different from the other graph that we had. The other graph that we had, right, the graph, instead of flipping back and forth, the graph, right, went up, came down, went up, and then kind of planed off, right? This is a lot different than the other graph, okay? This one, like I said, we had maximums, we had relative maximum, and we actually had a relative minimum because there was a set of an open domain, right, that allowed you to say, hey, here is what we said. This is a peak, right? We said that this one was a peak, and we said that this was a valley, right? Well, if we look at this graph, we don't have any peaks and valleys. We just have a line going up, okay? So that's kind of different. It wants to say identify our domain and our range, okay? Identify our domain and our range. Again, this follows kind of our cheat that we talked about earlier. So we have our domain. Our domain is always our inputs. It's a list of our inputs, which is our x values, right? I'll write that over here. Our domain, again, that is our inputs. And our inputs are our x values, right? Our x variables, okay? And also remember that, as we talked about before, our independent variables are our x variables as well. That's another thing that added in. So our domain, well, this graph is continuous. We talked about continuous on page 82. That continuous means that it is a line. This graph is a line. It's not points. It's not, this would be like the red here. This would be, well, that wouldn't be a function, but the red points, right? That would be a discrete function. Where this is a line, so it is a continuous function. And whenever we have a continuous function, we use these cheats for our domain and our range, okay? We use these cheats for our domain and range. Again, the variable goes in the center. So x and y, the variable goes in the center. We write our less than or equal to signs. We write our less than or equal to signs, okay? And again, domain it's talking horizontal, right? Domain talks about our horizontal from left to right, right? We want to write what is our, the domain wants to talk about what is our smallest x value, our smallest x value to our largest x value. And the same is true here. What is our smallest y value on the graph, and what is our largest y value? Okay, so when we have to identify the domain and the range of a continuous function, this is the cheat that we use. So we're going to say the domain, start my brackets, less than or equal to x, close the bracket, and what is the smallest value? Right? Well, this is a horizontal line, so this is my starting point. That is my starting point. Right? That's my starting point. That is at 0, 0. Here is my endpoint. And that one is at 200, let's see, 25, 50, 75, 125, 175, and 225. So that would be at 200, 175. Okay. So what is my smallest X value for this graph? Well, the smallest is the minimum here at 0, 0. So that's going to be 0. And my largest X value, which is here, is 200. So my range be similar. Less than Y is less than, draw my brackets. And what is my smallest Y value? Well, again, X, and there's my Y. Again, X, and there's my Y. My smallest Y value is 0. And my largest for this one is 175, which is different than what we did for this graph, right? The graph that we did up here, this was 0, 10. And this was 250, 10, right? If you remember with that graph. This went up to 110, right? This one went up to 90. And the highest point wasn't an endpoint. It was here. And that's okay, right? The highest point was here at 110. And that's okay. But for here, the highest point is the endpoint, and it goes to 175. It says identify the y-intercept. Again, remember your y-intercept. Your y-intercept is where the line crosses the y. I don't know what I was trying to write. It's where the line crosses the y axis. Where does this line cross the y axis? Right here at 0, 0. So what is the y-intercept? 0, 0. Absolute maximum. Absolute maximum. The absolute maximum, again, represents the highest. What is the highest? The absolute minimum, again, represents what is the lowest. Okay? What is the highest? What is the lowest? So what is the highest point? How high does it go? The highest it goes is here at 175, right? That's the highest. So the absolute maximum is 175, and the minimum, how low does it go? What's the lowest it goes? Well, the lowest it goes is here, which is the x-axis. What's the value of y on the x-axis? 0. So this is 0. Does the function have any relative maximum or minimum values? Explain. Okay. Well, in order for it to have relative maximum or relative minimum, again, if we look again at that example that we had for the first one, right, where the graph, the roller coaster did this, right? It had relative maximums and minimums, right? This here was a relative maximum, right? And then there was a point here at 90 that was a relative maximum. Why? Because we called those peaks, right? Relative maximums want to know, is there any peaks? Right? Is there any peaks? And again, relative minimum values, again, wants to know, is there any valleys, right? Like we had a peak here, right? We had a valley here. We had a peak here, okay? Even though the absolutes, right? One of the absolutes was actually here, way down here at an endpoint. Absolutes can be an endpoint. Remember that, right? Remember that absolutes can be endpoints, but relatives can't. It's because it's what it says. It's in a open interval. An open interval. An open interval doesn't include the endpoints. Okay. Again, with relative maximums, think of it like a mountain. You got to have an up and then a down. Okay. Think of a valley. A valley is in between two mountains. You got to have a down and then an up. All right. They can't be your endpoints. So, does this function right here, does it have any relative maximum or minimums? No, it doesn't have any peaks or valleys, right? And so the answer to number 9 is, of course, no. And you're going to say no. They're using the definition, right, is that there's no open domain. There is no open domain. Open domain, you know that as a peak or a valley that doesn't include the endpoint. There's no open domain interval that has a maximum or minimum. Okay, there's no peaks or valleys. Okay, there is absolute, right? There is absolute, but they're endpoints, and that's okay. That's not okay for relative. How are the extrema? Extrema refers to all maximum or minimum values, right? How are they different on the linear graph versus the nonlinear graph? Okay, well, on the linear graph, so that's what we're going to, all right, so on the linear graph, okay, where did the extrema occur? Where did the maximum and minimums occur? They occurred at the endpoints, right? So on a linear graph, the extrema occurred at the endpoints. Okay. On the non-linear graph, the minimum or maximum, for that fact, the minimum or the maximum could occur on points that are not the endpoints. On points could occur, let me drop that down, could occur on points that are not the endpoints, right? What that means is just like here, right? Our maximum for that first one occurred in the middle of the roller coaster. We think about that. Where is the tallest part of a roller coaster? Okay. Tallest part of the roller coaster is, of course, the top of it. Yes, you are correct. But it's not going to be, it's going to be towards the beginning because that's how you build speed, right? The roller coaster goes up to its highest point and then it's dropping down from that point on. It drops and it comes and it goes up, kind of keeping up the speed, but it never reaches the highest point again. It's always that first hill or the biggest hill, right? And everything else is down from there. All right. So that is 6 through 10 for, that's page 83, lesson 6-1, Algebra 1.